there's an interstellar comet right now coming in from outside of our solar system.
Three
right?
Eye Atlas 1.
3i Atlas 1, and it's
Or
moving.
Three Eye Atlas.
It's moving at a speed in our solar system of 150 kilometers per hour. But that's kind of maybe hard for some people to understand. Like something
150,000.
100. Yeah, did I say 150?
Yeah.
No, that's really slow. 150,000 kilometers per hour, 1,000 times faster than 150 kilometers per hour. Like what? I don't even know how to compare that speed to anything. Like what is like? How do you even quantify a speed that fast?
150,000 kilometers per hour. And I think that this
93 miles per hour, by the way.
93,000.
93,000. I keep forgetting the thousand.
So I think that the speed is actually like 130,000 miles per hour.
Okay.
But regardless, it's super high. We may have like mixed the numbers up a little bit. And yeah, you see something like that, and you're like, wow, how is this thing going so fast? And I think, perhaps you may think, well, this is way faster than anything that humans could do. There's nothing else in our solar system that looks like it's moving that fast. Maybe it's aliens, maybe it's some other craft. And I get why you go there, because for sure, the keys, the evidence is telling you that this thing is not from here. The easiest way to explain a speed like that is that it's literally an alien comet from a different solar system, right? We talk about like the Earth travels at 36,000 miles per hour or something like that around the sun, right? But the sun is also moving incredibly fast through the galaxy, but the Earth is moving with the sun, right? So the velocities are all relative.
Right. Because the Earth's velocity, even though Earth is orbiting the sun, its velocity around the galaxy is actually the same as the sun.
Exactly, which is why we stay in orbit around the sun and we don't like fly off into interstellar space.
Right.
And this is true for everything. You can almost think of the entire solar system as a vehicle, right? And the sun is kind of at the center of that vehicle. And inside the vehicle, there's like flies that are flying around. Relative to each other, they're moving at different speeds, but they're still in that vehicle, this gravitationally bound vehicle.
Right. So I guess a way to conceptualize that high-speed interstellar comet is like, okay, we're all driving like this Honda, right? And then there's this Ferrari that comes by, and I don't know, like they slam on the brakes, but then something crashes through the window at the speed that the Ferrari is moving at, and then it goes into the Honda.
Yeah, and you're like, wow, this thing is moving really fast.
Yeah.
And it's because it started in a system that just had a different relative velocity to us. So when we see it, we're like, yo, it must have come from, this car. Yeah, that's a. Yeah,
I just freestyled that. Yeah.
That was good.
Yeah.
I know. I was trying to follow. That was great.
But my question then becomes, how do solar systems develop different relative velocities?
Yeah, so you would expect some random dispersion, right? I think that the average random, let me actually look this up. I used to have this memorized when I was studying for my comps exam. Let's see, average.
Yeah, while you're doing that, little fact check on what we said earlier. So yeah, the 3i Atlas comet is traveling at 130,000 miles per hour, and it's 209,000 kilometers per hour. It's the fastest solar system visitor ever recorded. So I guess it spent billions of years in space doing its thing.
Which is how long it would take if it came from another star system, right? It gets ejected from somewhere. It's going to take a very long time to get to us. Let's say that, from that system, the sun basically looks like it's moving 100,000 miles per hour towards it. And this comet gets ejected and moves in this direction. It has a chance of encountering something like our solar system. It would have no chance of encountering a system that had a similar initial systemic velocity as it did, right? Because they're kind of like moving in the same direction. So it'll never catch up.
This is so interesting. So, okay, the idea of this comet is actually reminding me of a concept from Three Body Problem. So, for the book series, not the Netflix, not the TV series.
Yeah.
So, in the Three Body Problem, they proposed this dark forest theory, which is kind of a relationship to the Fermi Paradox, where it's basically like everybody's just hiding. Like all these intelligent societies are out there. If you reveal yourself, you make yourself vulnerable, right?
So they're scared of each other. Basically.
And I don't think that's like, I don't know if I summed up the dark forest theory perfectly, but it The most
Because I
important-
haven't read that book.
Yeah,
I haven't read that one.
I have. But the most important part of that I was really excited to talk about was the weapon that these intelligent civilizations would use against other intelligent civilizations, and it was called a photoid. And they would send an object at near light speed that would crash into its solar system's star, and then thereby wiping out the solar system of the intelligent civilization.
Oh,
Which I'm
interesting.
actually,
So that's why you want to keep a low profile.
because you get a photoid sent your way, and then
How did they like establish that that was standard practice for aliens that were like? How would you know that? How would you know that if we make ourselves known?
through, I guess, and these are like civilizations that have lived for a long time, right? And so like they've seen other civilizations light up in the sky, whether that be through radio signals or other forms that we've put out to make ourselves like, oh, everybody, look, we're here.
And they've seen them like go dark.
And then they immediately go, they have the technology to image this like high speed object traveling at their solar system. The solar system lights up briefly, and then the society goes dark.
So okay, so they pieced together that this
photoid was a weapon used to destroy other solar systems.
Yeah. I gotta read those books.
Yeah,
every time I ever start talking about three body problem, and
dude,
people
I'm telling you would love
tell me
it,
about the
man.
books, I'll have to check them out.
But that actually brings me to a question. Scientifically, I'm curious if your background would allow you to unpack this. So, if a comet this speed is 130,000 miles per hour, enters into our solar system and hits one of the planets in our solar system, like what might be the outcome?
So I guess it depends on a couple things. How big is the comet?
Right.
I think that they said it was the size of Manhattan. Nah, that sounds big.
The estimates range
Smaller
from a
than that.
few hundred meters to potentially over 40 kilometers, over 25
So
miles.
that's a
in
big
diameter.
range. So that sounds pretty big. That's not something that you'd want to get hit by.
Right, like as a planet. Like if you're a
Right.
planet, you don't want to get hit by that.
Let's see, the asteroid I believe that hit and wiped out most of the dinosaurs was the non-avian dinosaurs was like the size of a city. I guess we could just look that up.
Yeah.
But it was much smaller and it was not moving nearly as fast. Right? Nothing in our solar system is moving at that speed relative to the Earth.
Yeah, it was about 6 to 10 miles in diameter. The one that wiped out the dinosaurs.
So it's about the size of a city and it was probably moving at like half that speed.
So curious about the speed.
Chicxulub crater? The Chicxulub
It says about 45,000 to 67,000 miles per hour.
Okay,
so
yeah. So
close to like a little less than half the speed of this comet.
right. So this comet is, basically moving twice as fast. So there'd be twice as much energy, assuming that they're like roughly the same size. It sounds like the other one might have been a little bit.
Plus or minus.
Well,
it's
we don't know.
range,
There's some, So I mean, you definitely wouldn't want to get hit by that.
Yeah, like if that hits Earth, we're cooked.
But and then you can just think about like, well, what are the odds of it hitting Earth? You think about this thing; it must have gotten ejected billions of years ago to have reached our system. What are the odds of it? We would be the most unlucky planet, like in the universe ever, to get hit by literally an interstellar comet that was ejected many billions of years ago.
Unless it was an alien
Right.
civilization.
But I guess, if you think about it like that, right, that would have been, and that's something where you're like, okay, the odds of this happening are so slim. Oh, what was this done on purpose?
Was this a photoid?
Yeah, it's not very elegant just having it be a big comet. But I guess it works. In the Expanse, I forget what exactly the storyline was, but that one of the things that they were doing is these were people in the resistance or like the revolution. What did they call them? The Belters?
Yeah, the Belters. Yeah, I just started watching it. Not a fan yet. I gotta say, like the world building was great, but I think the storytelling so far kind of MIDI.
How far are you?
I just finished episode 1, season 1.
Come on, bro. You finished episode 1 and you talking about the world building and the narrative.
I feel like the first episode's got to hook you in.
Nah, bro. Give it a couple episodes.
I'm gonna try, man, because I feel like that's the thing I do though. I'll like write off something pretty
spoiler
quick.
alert.
Oh wait, no, it's okay. Yeah, I guess for the audience.
Spoiler alert. What they do is what they do at one point is they're like taking these asteroids and they're flinging them at I think planets. I haven't seen it in a while. I think planets, but they're just using them as bombs, really, which is
Wait,
it's
they're using
basically what it
planets
is.
as bombs?
Asteroids.
Asteroids as bombs. Okay, yeah, that makes so they're flinging them at
Yeah,
planets.
yeah.
Wow.
They're definitely not flinging planets at
Yeah,
planets.
that would be crazy.
That would
Yeah.
be insane.
But even flinging an asteroid, you have to generate a ton of force to do something like that, right?
Yeah, I mean, it's in the future or something, so
Yeah, but
just
it's
gloss
the
over that.
belters who are like less funded, I guess, in the society.
Yeah, well, I guess one of the interesting things in the Expanse is that there's really this element of there's like this almost caste system
Mm-hmm.
where people on Mars, uh, they can't go to Earth because they develop under like Martian a Martian gravity, which is much weaker. I don't even think you could really survive. Our bodies really aren't meant for that. But then you have the Belters who grow up like in basically no gravity,
Mm-hmm.
super low G. And so they really can't go anywhere, and they're also like seen as the worst, and they're also like minors. They're kind of like the low, like the working class of
Mm-hmm.
that. It's really good. Anyways, you
No,
should continue to watch that.
I saw that part of it so
Mhm.
far, and then I think they were like there were belters or folks from other planets that came onto Earth's surface, and then they were like the gravity of Earth was just so debilitating for them to like
Yeah,
be in, and yeah, they would like use it as torture. I think in the first episode,
yeah,
I was like, man,
yeah,
that's crazy.
yeah,
Yeah, so
yeah.
that part is fire. So yeah, I have
The
enough to
torture
go to
part.
episode 2,
Yeah.
but yeah, I feel like the storytelling. But yeah,
But
maybe I'm just a
we're
snob.
talking about the comet. So among the stars in the Milky Way, there is this dispersion of like somewhere around 20 kilometers per second, right? So if you just randomly sampled stars, you'd expect them all to be basically within 20 kilometers per second
Hmm.
velocity of each other. That number shoots up if you go towards the center of the galaxy where there's more stars,
Hmm.
more like gravitational potential. Things are going to be, flying around a little bit more crazy. But overall, right, everything is orbiting around the center of the galaxy,
Huh.
but there is a dispersion amongst those
Right.
things, right?
Right. So you're saying in the middle of the galaxy, things are more chaotic. So it's
Oh
more
yes,
likely that interstellar objects are going into the solar systems of stars in closer towards the Milky Way or closer towards the center of the Milky Way galaxy.
yeah. I guess you would say that on average,
Right.
there's a higher likelihood for something
Interesting.
like that to happen because things are getting kicked out more frequently.
That sounds chaotic.
Yeah, it is. It would be crazy in the inner solar system, or I'm sorry, in the inner galaxy.
Hmm.
And I actually made a video about this maybe a couple weeks ago, where one of the answers to the Fermi paradox could just be that we're too spread out.
Hmm. The
And
Fermi Paradox being, just for anyone that's not aware.
yeah, that we haven't found aliens.
Hmm.
Basically, that's what it is. We haven't.
Like why? Like we've been looking. Why are there no aliens?
If the assumption is that life is common and that intelligent life is common or likely, if we assume those things, then like how come there's not any evidence for that? And I think the most simple answer, the one that requires the least amount of assumptions and
Hmm.
hoop jumping, is just that it's too far apart. You can never travel those distances, right? If you want to if a comet gets ejected from a system, it's going to take billions of years to get to another star, as we
Yeah.
see with 3i Atlas. Well, what if you go somewhere in the galaxy where the stars are closer, like the center of the
Hmm.
galaxy, and you do solve that problem? Stars, instead of I think our closest neighbor Proxima Centauri is like 4 light years.
Hmm.
So around our distance from the center, you could just use that as an average and say that stars are about 4 light years apart. It probably vary a little bit. But if you go to the center of the galaxy, that number shrinks, right? Stars get closer and closer together. If you're like at the galactic center, but still a little bit ways from the supermassive black hole, that number maybe goes down to like zero point 0.1 or 0.5 light years, under
Hmm.
a light year. And so that's still a really long ways, but those are more reasonable than 4 light years, 5 light years.
So we're in like the suburbs of our galaxy.
Right. And
Yeah.
there might be a reason for that, right? And this might be like a survivorship thing.
Hmm.
While you solve the distance problem as you get closer to the center of the galaxy, you have another problem. And it's like a life and a planet problem. If you have a whole bunch of stars that are close together, because it's chaotic, they disrupt each other. and they would disrupt the disks that are around the stars that need to be stable for planets to form. Right? So you could imagine, when our solar system was young, it was this huge disk, and the disk itself was chaotic. Stuff, stuff was crashing into. Just recently, there was a paper that came out from the InSight seismograph on Mars that showed that it seemed like there were chunks of something different inside Mars' mantle. Almost as though there were rocks that didn't belong there, like pieces of perhaps some other smaller planetesimal that crashed into it, and they just kind of stuck there. And I think that that's consistent with how we view the early chaotic solar system. So it's okay if the disk is chaotic, but you need it to be stable overall so that the planets can form. And so all this crashing and stuff can happen.
Right.
But if you have stars flying around, they're going to tidally disrupt the disk. And then once you start spreading that disk out, you no longer have enough stuff concentrated to make planets. Then the fact that they're radiating, they're just putting out a bunch of energy, also evaporates the disk. And kind of, you can imagine what happens to gas when you heat it up, kind of puffs up and dissipates. So you have these two things happening to the disks around young stars that are trying to form planets as you get closer to the galactic core. So I don't even know, it's hard to observe exoplanets that are so far away. So we haven't really found any planets in that area. It's not that they couldn't exist, but based on the theoretical formation scenarios that I just put forth, it would be reasonable if planets aren't even common around there, much less life.
That's crazy, man. That's actually like fascinating to me. I've never heard that before.
Right?
Yeah.
And so as you get further and further away, you can have more stable disks, but you're farther and farther away from the other stars. And so you could almost think of the galaxy itself having a Goldilocks zone.
Or like a habitable zone.
Right?
In
where
theory,
it's like,
right?
Exactly. Where and this habitable zone would, it would, I guess the root there would be, can you form planets? As opposed to like, can there be liquid water? But, that would be buried down in the, can you form planets?
Right.
Yeah,
man, but like on the other side of that, I'm like, imagine a lucky pocket of civilizations or intelligent life that's able to form in like very close star systems towards the center of the galaxy, and like how cool it would be to just have like stellar neighbors.
So cool, right?
Yeah,
yeah, and I mean, we don't know.
Maybe it wouldn't be cool to them. Maybe they wouldn't care.
Well, yeah, I think it's hard. It's hard to.
Can't know.
It's like hard to. I mean, maybe that wouldn't be so different from having a planet with people on different countries.
Yeah.
I guess it depends on where you are in your evolution, because the first time you found out that there were people on the other planets,
oh my God,
well, who knows what happened?
Well, yeah, I guess for us it would probably be a big deal.
Yeah.
Yeah.
And maybe maybe we're like exactly where we need to be. I don't know if we have the temperament to mix and mingle with the galactic colleagues.
Yeah, I mean, yeah, it's kind of hard to imagine what would happen if we hung out with an alien species. Yeah, because we don't know how they would be either. Their temperament could be...
No idea how they would be.
Yeah.
I'd like to think that we would get along as well as we get along with animals that we didn't evolve to be closely related to. So that's like...
like killing them all. Or driving many of them to
extinction. I don't know. Pick
one.
one.
Them in zoos
a hippo, a wolf.
Okay, extinction,
woolly
domestication, admiring them
hippos
in
kill
zoos.
people.
Hippos do kill people.
Yeah.
We kill hippos too.
Mosquitoes.
We
and it's like mosquitoes don't see us as enemies.
Yeah,
actually see us as delicious treats.
Yeah. They have like kind of a parasitic relationship. Yeah. So we kind of see them as vermin. Yeah.
I hate mosquitoes.
Yeah, we have one in the room, I think, still.
We have a mosquito in the room.
Hey, everybody, if you like this clip, check out our full episode of Curiosity Theory, linked down below.